computer. So in response to how do we see the previous lectures, let's go ahead and share my screen, screen one. We can see over here, go to our class. We go to over here in the lecture recordings button over here. Click here. We have all our lecture, and this links to our YouTube page. And then not sure where lecture 5 went, but lecture 6 is there. Yeah. So we have a playlist here where you can view our previous lectures. If I'm missing one, let me know. I'll try to update it. I think I'm missing one. I'm not sure which one it is. Yeah, I'm looking for just something that's indestructible. Seems pretty good right now. If all the presidents have used it since LBJ, then I think it's probably in the if it ain't broke, don't fix it category. All right, furthermore, we are going to we have the turtle sequences and for loops. That's a lot. Module 4 is where not necessarily the difficulty cranks up, like it doesn't like plateau for a, it's more like this is like a temporary spike in difficulty where there's just a lot of information to absorb. I fixed the links down here so you have all the exercises, and the quiz has been posted. That is due, oh, you can check your assignment. We can check our assignments over here for when it's due, the 26th. So you've got a while yet to do quiz 2. That one is a mix of for loops and turtles. All right, when you get the chance, could you explain why trying to print slash or versus slash is funky? Yeah, give me a sec. And we have these exercises. This one over here is useful for constructing lab 3 and learning how to do functions. Our current assignment is a fairly large assignment. I notice it's 180 points. And note that basically there's a lot of there's about 14 pages worth, but this is for 2 weeks worth of stuff. So, and most of these build on each other, or sorry, a lot of these will build on each other. So over here, let's see, 99 balls, multiplication table, and summation of squares don't really build on each other. They're just there, but a lot of the turtle ones do. So like so here, like these ones where I have you draw a square, then drawing a row of squares. No, I haven't looked at the document yet. I planned on doing that tonight. It's just been, it's just been a bit busy with unexpected computer repairs and stuff. Can I explain the squares? This one is due September 29th, so a while from now. Like I said, this is going to be basically assumed to be the lab for both this one and the next one. And yes, this quiz 2 is about turtles and for loops. So my turtle square size. Basically what you want to do here is fill in these functions to create functions where you have the turtle, my turtle, draw these various things. So here, draw square. Now here you can use that to draw a row of squares. And then from there, you can have him draw a grid. And then from there, you can also do a step of squares. Then you'll have n-sided polygon. Andrew, that is correct. You only have to show the result. And then do this one. And then I have some bonus problems here. Okay. It may look very complex, but they build up quite but these functions the turtle functions build up quite easily. on each other. And they're meant to show you that doing one function can help you. So because, for instance, you have a draw square function, so you should draw a bunch of squares in a row. You should call draw row should call draw square, and a grid is just a bunch of rows. So you should call draw row. No, I've not looked through the problems of quiz 1 yet. I will try to do so tonight. Like I said, I was dealing with some technical difficulties at home over the weekend. Right, not everybody's on Discord. My wife's computer broke, and so after decades of use, so I've basically spent the weekend putting it back together, or with new parts, building a new computer. So that's what I was doing, because we're very data-centric people. Yes, success, it works. It's a 5600, it's no graphics card. It's using a AMD 5600G, which has an integrated graphics card. Very good. All that means is that if it's going to be perfectly fine for playing Civilization 6. But she primarily uses it to do actual work on. So, all right. So this one, again, this one may seem a bit like a lot, but it's also for lab. This is not only lab 4, this is also lab 5 as well. Okay. So next week, you're not going to necessarily get an additional one, although we will be doing an exercise. If we have time for it, we'll have an exercise next week. That's one I typically would give then. The quiz covers for loops and turtles. It doesn't go over lists and other, so take that when you feel you've got a good mastery of for loops, typically when you're mostly done with the homework. But again, that one isn't like until the 26th.
And what's the homework?
The lab.
Oh, the lab. Okay.
The homework lab. Okay.
Good.
So, okay. Now that, if your lab section is on Friday, will we have a lab section next week? I don't know what you're saying. I mean, you're going to have lab no matter what, right? Is there something to... Which labs are due next Wednesday? This is due the 26th. Yeah, lab 4 should be due the 29th. So that's a while from now. I mean, I can extend the due date to the 1st, but if a lot of them are the same, then you should probably have no issues with doing them. The turtle lab is due tomorrow. You have to demo every lab assignment. Yes. Okay. So let's go ahead and yes, you can always demo after you submit it. In fact, that's the way it's supposed to work. You can demo, you have up to 2 weeks after you submit it to demo. Okay, but the sooner you submit it, the sooner you can fix anything that you might have a mistake about. All right, so today's operation is about passwords. Okay, passwords are basically the first thing you have for security. So if you want to find this, go down here, click, go to module 4, click here. I'm also just gonna be lazy and drop it in the chat so everybody can see it. Everyone in meeting, boom. Okay. All right. So today is about, here we're going to learn how to generate passwords today. So this is about generating an XKCD style password. If you are unfamiliar as to what XKCD is, and hopefully it's a good comic today, this is XKCD, which is this is a comic about math and science related things. it is pretty good. They also have a, he also does, as I've shown you, also does a comic. He has a blog about what if, which he comes up with he comes up with answers to very weird questions. Would a toaster still work in a freezer? Or what if the entire U.S. continental U.S. was on a decreasing slope from west to east? How steep would the slope have to be to sustain momentum without pedaling? Can we flood Death Valley? How many fireflies would it take to match the brightness of the sun? So he's basically trying to figure out stuff for that. Anyway, he has, yes, at least 3. So he has this kind of, so one of the things that Temple actually does really well security wise, besides enabling 2-factor authentication, is their password policy, which is that the more letters you have, the less strict the requirements become. So for instance, let's take a look at this kind of password. You take a weird word like troubadour, make some substitutions that are common, like, okay, I'm going to put an O, a 0 instead of an O, a 4 instead of an A, add the random punctuation and number that you have to add or something, right? And the idea here is that when this comic came out, you could do about 1,000. It would take about 3 days to guess that password if you were just trying to go for that password. But the issue, so it's not too hard for a computer to guess, but for you to remember, it sucks, right? It's a terrible password. It's just hard. Right? It's pretty tough to remember those. But take this password that's made out of 4 random words. Correct horse battery staple. This is much, 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 much longer, even though the combinations are less, like I don't have to worry about numbers and random punctuation. Even though that's less, it's got less those. It's much longer. Correct horse battery staple. Takes much longer to guess, 550 years according to his calculation. And difficult to remember it. You've already memorized it. That's a battery staple. Correct horse battery staple, right? So the idea here is that, and so we can see this with Temple's password system, where if you just simply use a bunch of words together, you can have a long password, more of a passphrase than a password. But you don't have to worry about all the weird exclamation points and the numbers and stuff. These are actually much better because, again, humans remember them, and because they're long, they're harder for computers to guess. Okay. So, and that's kind of the idea here. Okay. So today we're going to learn about, or we're going to use randomness. So I forget, I think last week's mod, the import, when we were talking about import modules, we talked about randomness, right? Is that correct, or am I misremembering? Okay. So randomness, again, we are going to leave the philosophical discussion of what is randomness aside, right? Because, like, if I have, a die, right, and I roll it, pretend this is a 20-sided die, right? No, this sphere of Earth, right? If I give you like the amount of force I'm going to give to it, and the state of the room and how far it's going to fall, you could probably calculate, what side it's going to land on. So is that random? Is a coin flip really random? Is there anything such as free will if nothing is random? We're going to avoid that existentially horrifying and question about determinism. And and stuff, and basically say computers can't really generate random numbers. They can't. They can generate, because they have to use math to figure out, to generate numbers or to do random decisions. They have to draw that data from somewhere. So what they do is something called what we use with random things in computers are what we call pseudo-random. They are statistically random. So there's this really useful function, okay, in random that I find that basically one of those things I love about Python, which is a function called random.choice. So here, if I do random.choice, and we see this string of numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. If I say random.choice numbers, print this. Okay, everybody sees this. I'm going to run it, and it gives me 2. And if I run it again, it gives me 6, 4, 1, 7, 2, 1. So what is this? Well, this is a sequence of letters, right? A sequence of a bunch of characters, a bunch of glyphs. And random.choice says if you give me a sequence of some kind, be it a list or a string, I'm going to select a single thing out of it at random. Okay, makes sense? So here I've got a random letter, a random I've got letters, I've got capital letters, and I've got numbers. Okay, and I can just say random.choice numbers to select a random thing from that. Make sense? Did you import random? No worries. Okay. Now, before I move on, there was a question about 10 minutes ago that I want to answer, which was, why does Python act wonky with printing certain stuff? Like if I try to do, print, why is this not working? This has to do with, versus if I do this though, that's fine. Your issue is going to be with these slashes. Yeah, no worries, Sammy. The issue is basically that we use these slashes over here, specifically the this slash, as what we call an escape sequence. To use it for special characters. Remember, when I was doing /tab to do /t to do a tab, to print out a tab, that doesn't print the low. You use /t for a special. You use the slash for a special command, an escape. So we call that the escape sequence. So here that printed out a tab. Similarly, if I were to do /n, that would give me a new line. And so the idea here is that so when the computer sees this kind of slash, was that a / backslash? I don't remember which side is which. Anyway, the idea here is that basically when the computer sees the symbol, it says, hey, okay, when it sees the backslash, it says, hey, where is yeah, I always know that, but I'm never like 100% sure. I'll go back in a second. So when it sees the backslash, it's saying, okay, the next character is a special thing. A /t. Okay, you don't want me to print out / and t literally. You want to do a tab. You don't want / and n literally. You want a new line. That if you use 2 slashes, if you want to print out 1. Okay, now going back to line 7, print random.choice numbers. This will choose a number at random from all this. Okay. So our first task is we want to create a traditional 8-letter password by combining the characters of these 3 strings. Okay, So use the fact that we can use random not choice, and we've got these 3 things over here to make an 8-letter password. A random 8-letter password. Okay, so I'll give you 5 minutes to try that one, and then I will come and help you. Would you like me to split you up into breakout rooms for this?
Yeah, sure, why not?
Okay. Okay.
Thank
So I'm going to go ahead and so again, to find this, this is on our textbook all the way at the bottom. This is project 5. We also got there from there. Also, you can click on the link that somebody was posted, which I was about to do. So check in chat. Okay. The link was just posted. So let me go ahead and breakout rooms. Assign automatically, create 100, no, not 100. Create 40 breakout rooms. Assign automatically. What you got to do is you want to make an 8-letter password by using some combination of random dot choice and these 3 variables. There's a lot of valid ways to do it, so I'm not going to pre-prime you with a way to do it other than using random dot choice to do it. There you go. Yes, that's fine. Yes, that's fine. You can, yeah, if you're not feeling 100%, then you can go ahead and just step out.
Thank you, Professor.
Mhm.
Good day.
Okay, so now let's see. Stop share.
Professor Rosen. I ran into like a problem with my random characters. I was wondering if you could take a look.
Sure.
All right, I'll just
Go ahead. Let
should
me
I speak?
enable.
Okay.
There you go. Screen sharing's enabled.
Okay. Got it. So I chose to do it like this. I assigned a variable for all of this, and
Ah,
every time I did this and printed it, it would work. But even when I did the loop, or when I just did after this comma print random dot choice of A again, and I would just copy and paste that 8 times. I found that some of the variables would repeat most of the time, and I was wondering if this is like an error that's like in the system by using the same variable.
yeah, because you've only gotten 3 variables from that. You've only got A is only 3 things long. Print out A.
Yeah.
So, but if you print out A, you'll see it's only like, in this case, D2 and Y.
Okay.
So what
Oh.
you're on the right track though. I'm gonna pull everybody back in a couple minutes to show, but what you're gonna want to do is try concatenating the letters, the caps, and the numbers, and pulling your random thing out of that.
Okay. Thank you.
Make sense? So A should be a concatenation of letters, caps, and numbers, not a random choice from it. You're on the right track. It's just a matter of getting of writing out what you intend, you know?
Yeah, so at the top of the screen where it says like right under import random, where it says like letters and it's only just lowercase and caps, it's just so should I have one variable where it's like all the lowercase, uppercase, and numbers?
Yeah, but you can do that by just adding together the 3 variables that already exist.
Okay, thank you so much.
I'll be showing that how to do that when I bring everybody back in 1 more minute. Okay. Breakout rooms. Close all breakout rooms. Be there in a second. All right. So yes, I'm going to be showing you how to do this task now. Okay. So let's go ahead and take a look. So over here, we've got our, let me go ahead and reload this. Load history. So we've got our choices over here. So let's think about what we need. We want to make an 8-letter password, which means we want to select something 8 times at random. So if we want to do something, the exact same something 8 times in a row, that means
Don't you have to create an array in order to put this, to put the variables or the string into it?
Not in Python. Python's wonderful. Okay, there's a, so if you're coming from a programming language, you got to start there. Part of it is using these. Ben has it. Yes. Ben has the most Pythonic answer, I believe, is the best way to put it. So for I in range 8, we're going to do this 8 times. And we're going to say we want a password. So I'm going to say password is equal to, so we're going to use a weird variation of the accumulator pattern here. So like for instance over here, if I were to do password is equal to 0 plus, sorry, is equal to password plus stri, print password, right? Oh, if we see over here what we're doing, run it, we get 0, 1, 2, 3, 4, 5, 6, 7. So remember, the plus operation when you're dealing with strings is called concatenation, right? You can add strings together. Very cool here, right? And we can do this over here. So I started with an empty string, which is essentially the string equivalent of 0. Okay. Then what do? I add 0 to the end of password, so it becomes 0. Then I add 1 to the end of that, so it becomes 1. Then I add 2 to the end of that, so it becomes 2. Then 3 to the end of that, and so on and so forth. But that's not really going to help me now. Rather than adding I'd rather want to add random dot, well, what if I do random dot choice letters? Okay. So what I'm going to do here is that I get DKFZ Zinwill, whatever. Save and run. Okay, very, very unpronounceable things. This seems like we're getting into Cthulhu-ish territory. So anyway, the idea, so but we're able to create a password like this, but we don't want to just use the letter here. Sneha, yes, that is correct. So I don't want it to just be letters though. What I can do is that I can make something like all. Except all seems to be a keyword in Python. So I'm going to call it all options or all cars. Yeah, all cars is equal to letters plus caps plus numbers. And I'll just print that out so you can see what all cars is, short for characters. And I'll put it down over here. So what I did with, I hear you, Mark. So you'll want to check to make sure that you're importing everything and your indentations are correct. So what we've got over here is that we've imported random. I've taken these 3 variables together and I've combined them into one variable. See, the all chars contains all the lowercase letters, all the uppercase letters, and 1 to 0. Now this is awesome because now I can just randomly select from all of them. Make sense to everybody?
Yeah. So
Oh,
you're
wow.
changing
Yeah,
from
that's
3
not-
different variables to 1.
There's a lot of ways to do this. If you wanted, however, it does not guarantee that you're getting at least, how to say, it doesn't guarantee that you're getting at least a certain number, right? Like here, I've got myself a 0 and a 7. It doesn't necessarily guarantee that I'm always going to have a capital letter or a number. Like here, we almost didn't have a number, right? If I wanted to do that, I could do something like do 6 and add on the letter. Then if I wanted to guarantee it, I would have to do something like this, where I would do 6 letters and then I would do, let's see. caps, and then numbers. So here I'm discarding using all characters. And notice that I get 6 letters, a capital letter and a number. Now, this could also be considered a correct answer as well. Now the question is, what is the password equals 0 for? Password has to start out with something, right? Password has to be initialized to some value, okay? And this is the equivalent of 0. This is the empty string, meaning it is a string with 0 characters in it. And now what this does is that this adds a letter into that string. And then it adds another letter until we've got 6 letters in the string, because 0 plus 6 letters would be 6 letters. Make sense? All right, so some people are having difficulty. So what I'm going to do is I am going to go back to this password, because this one, because I like it and it's more thing. Also Zoom, it looks like it's crashing again. So no worries. I'm going to hit share code. This will give you the code, give the code to everybody. So if you reload your page and hit load history, you will now be able to see the code I just did. I'm going to stop sharing for a second because, again, I just mentioned that Zoom is crashing. And then I will be right there because I am going to manually kill Zoom. Because hopefully they'll update it soon. Because okay. So somebody says I didn't see your code when I refreshed the page. Did you hit load history?
Yeah.
Okay.
Not sure if it's just a me thing or not.
Let me see. In fall 2020 Rosen. So
I see that one. I don't see the most recent one.
that's the one I want you to have.
Oh, that's the one you shared.
Yeah.
Okay, perfect. Thank you.
Yeah, this is the one I shared because this is the one I like more. Okay. This is the one I like more. So the question was for Matt, why wasn't the other 2 indented? Because I wanted this to happen 6 times. So it was in the for loop that runs 6 times. And I wanted these things to only happen once. Yes, Amul.
I mean, my question was that instead of the I, could you not just put password there for I? So instead of I, password
The
there.
password
and-
would then keep getting overridden by the by this.
Oh, right.
PJ.
What is the difference between using the for loop with a range of 8 and just keeping it with all chars versus the for loop with a range of 6 and then adding those 2 lines underneath it? Because when I was running it with the range of 8, it was not the same, obviously, but it was in a similar, like it was the password that we were looking for.
So I just ran this because I kept hitting it. This one didn't give me any numbers this time because it's completely at random, right? So here we are choosing from all of these at random. And that means that sometimes we might not get the numbers in the past, depending on how strict our password requirements, we might need a number in that, right?
Okay, yeah.
Okay. So why is the password equal to string? This is the equivalent of me when I'm initializing a number saying it's equal to 0 when I'm doing an accumulator pattern. Does that make sense? So an accumulator pattern, right? When we were summarizing things, when we are summarizing things, we add to it. So we have basically had to start with the first thing to add on to. Yes, Alex.
Maybe. Okay, so I'm realizing that I approached this assignment, I think, either just very differently or more likely extremely wrong compared to like what you did, because I didn't use any loops at all.
Mm-hmm.
I kind of just did, okay, print like random choice numbers plus random choice caps plus random choice numbers plus random choice letters like 8 times, like, and just like mixing and matching to get 8 characters. And I'm getting like an 8-character password printed that
Right.
has numbers, caps, and things, but it's definitely not like yours, and it's not the way you're doing it. And I just,
Now,
I'm
that's
realizing
fine.
that like,
That's fine. I would say, I didn't, that's why I said I didn't want to mention, I tried to avoid using the word a for loop just to see what students would do. Because a valid approach would be to do something like this: print random dot choice and then letters plus. rather
yeah,
than
that's
just-
exactly what I did.
That's perfectly a valid choice to do.
Okay.
That's perfectly about it gets the job done, is what I'm saying, you know. So
Professor, what I decided to do is I did a little different where I made a for loop. And then I decided to do like a for I in range of 8. And then if I is, module 2 equals 0, print letters, otherwise print numbers.
yeah,
in
sure,
order-
that works.
That would have worked too.
Yeah. All
Thank
right. So now we can use what we learned here to do actually what's going to be a bit of a bit one. Use what you learned above. And now we're going to do this one. And we're, instead of doing this these random hard to remember passwords, we're going to do the XKCD passwords. So here, here we've got a sub-selection of the entire dictionary. We've got nouns, verbs, and adjectives. We don't want to use the entire dictionary because of the Scunthorpe problem. So what we're going to want to do is select 4 random words and concatenate them together to make our password. So make a 4 random word by concatenating by combining words from the list of nouns, verbs, and adjectives. So go ahead and now, using basically what we've done above as kind of the base, instead of using letters, caps, and numbers, doing this. So now these are lists, okay? Let me just answer one question that some students may have. These are lists, the things in brackets. They're a list of strings, which means that if I do, remember, we got to import random. Almost forgot that, actually. It's a very common thing, even doesn't matter how far you are into this. If I do print random dot choice, and let's go with verbs. The verb is the word. Okay, we'll get a random verb, such as suppose and born or date or finish or waste or purchase, right? Because we're doing random, remember, random choice selects a random thing. Here, the thing, since these were strings, the thing was a letter. Since the thing here is a list, it selects a random item from the list. So for instance, if I had numbers over here, you're not going to want to use this numbers. It's completely irrelevant, but this is just trying to I'm just trying to illustrate a point with the list, right? Apples is not a number. Don't worry about it. It got apple 1, 4, 2, apple 2, apple 4, 1, 2, apple 5.0, right? This selects a random thing and a random item from the list. What an item is separated by the comma. So using what you've used above for the strings, do the numbers. Now, using what you learned about for the strings, now do it for the lists to create a password of 4 random words. Yes, Hirab.
is there a way when you want to print two variables to put it together on the same line? Like with no space between them?
With no space between them.
Yeah.
Concatenate them. And then if they're number and if they're not strings, turn them into a string by putting them into str.
Oh, okay. All right, thank you.
Concatenation is the way to you glue adding strings means you concatenate them together. That means you glue them together without any spaces. All right. So I'm going to split you up into rooms again and give you another 5 minutes. Hopefully this should be a bit easier with the code that I have given you as now as kind of a primer. So breakout rooms, recreate the breakout rooms, different people, musical chair shuffle, go.
Professor, I fixed my code from the last one with the letters, caps, and numbers, and I'm not sure because every time I put it through the for loop, it prints out as a new line each time, and I'm not sure like how to make
Because
it in
you're
one line.
probably because you have the print statement inside the for loop, as opposed to having a concatenating like I'm doing.
Okay.
Mhm.
Can I share my screen and show you what I'm doing?
Sure. Let me stop sharing.
Okay, here, instead of making random not choice with a
Yeah,
comma, I
so
added these.
yeah, I see that. So what you want to do, your issue is that you're printing out each thing. What you need to do, you know how I have password equals empty string in mine?
Yeah,
Yeah, that's because so I'm saving all those characters that you're printing out. Rather than printing them out, I'm saving them and adding them to the password.
yeah. I tried doing that like this. I just moved the line that was up here inside the for loop.
That
But it
won't
just-
do anything, no,
Okay. How do I like?
because you're not telling it to do anything.
Okay.
It does exactly what you're telling it to do.
Okay. How would I make it be one line? I'm not sure where to go from here.
The way I did it. If you share your screen again, reload the page, hit load history when it pops up.
Okay.
That's how you do it. With no lines 11 through 13. That's how you, or 11 through 14.
Okay, got it.
That's how you add it on. I'm concatenating on to it.
Okay, thank you.
No worries. Okay, so just as a reminder to everybody, I already sent out an email about this, but we will not be having class Thursday. A not insignificant minority of students would be missing class anyway, so so I don't really see a reason to make it up. I will post a lecture if you, I will post a lecture. I'll try to find a lecture from last time I did this and post that in an announcement for everybody so that that can be reviewed on this stuff. But again, no lecture, so you can take off Thursday. That also, furthermore, that does mean that I'm not going to be holding office hours on Thursday. And if you try to contact me between sundown on Wednesday to sundown on Thursday, you're not going to get a response from me. Okay, until after sundown. Yeah, it's the last parts that are hardest because you're like, can the sun just go down faster, please? It's I'm not doing anything but waiting for it to go down at this point. So yeah, I am unavailable from sundown Wednesday to sundown Thursday because Jewish holidays are weird and go from sundown to sundown, or maybe it's that every other holiday is weird and they go from dawn to dusk. So so that's all. Regardless, if you want to send if you send me an email, I will answer it in time. Okay. So regardless, let's go ahead and take a look at what we need to do. It can be, but it's nice to have an excuse to get together with people when it's not COVID. All right, so let's go. So this one is fairly straightforward. So password is equal to, like we did over here. Okay, now we do for IM range. We need 4 words, right? We need 4 words, right? So rather than doing 8, we need 4. Now what we're going to do is I'm going to call this words rather than, and we're going to do nouns is annoying. Now the keys are right next to each other. Nouns plus verbs. I swear I know how to spell. Nouns plus verbs plus adjectives. There we go. Thank goodness adjectives was abbreviated. Otherwise, we might never get this done. All right. So now we've got our password, right, initialized to store the words as I generate them. So what I'm going to do now is I'm going to say password. And I could just do is equal to password plus what we do next, but I'm actually going to use a shortcut here, and I'm going to use this, which does the same thing. And so random dot choice is there any difference between this and that shortcut? No. It's just an option, and I want to show you that it exists. Random dot choice words. So this just means add to what's stored in here this value. Don't replace it, update it. The for IM range So for the iron range, just think about how many times you want to do this. For our assignments right now, we have an exact amount of times we want to do it. The 4 iron range thing, though, if you can't feel that you're getting it, the key is, and you're going to hate me saying this, practice. It takes a bit of time to get used to it. So here, how do you know if it's using one of each? Like it just could be using nouns or verbs or adjectives. Ishan, that is an excellent point. We don't know, but fortunately, you know, I don't really care in the same way that I did over here for character classes. Claim transfer following frown. Isolation suppose uncomfortable free. Tissue just suggestion balance. Spend key transform unfold. So those are some passwords that we could get. Okay, 2 questions which are very, very similar. If I wanted to add a space between them, is there a way to add a space between them, or does that not matter? Or if I wanted to do a space, how would I do that? There is a way to add a space between them. Unfortunately, we are going to run into something called the fence posting problem when we do so, but that is how do I add a space in between them? Yep, Conrad's got it right. First off, in a password, I generally don't put spaces in, but if you wanted to, sure, why not? You would just do a space like that. Now, here's the fence posting problem. Limit bottle voice born. Okay. Might be a good question. Why don't we define the I variable we use in the for loop the same way we do the password variable? Because the I we don't actually have to use. I could just simply survive without it in this context. But people freak out when they see this. But this means that here we're just using I and not creating it, and nothing stops us for I hit strike. Nothing stops us from doing this over here. But the difference here is what we call scope. If I have this I over here, it determines that I should exist outside of the scope of that for loop. But anyway, I want to get into this fence posting problem because it's one of those frustrating things. Shared, intense, pull, present. And notice that we've got a space added at the end over here. So now it's called the fence posting problem because we've got these fencing over here, and we've got posts, and you want to have one less of one. So the idea here is that basically we've got an extra bit of fencing over here going out from one of our posts, right? Here's a post, here's some fencing connecting them, here's a post, here's some fencing connecting them. So how do we get rid of that? Well, somebody said, Ben said, you can just simply strip it out. That's an excellent suggestion. Strip removes any preceding or following white space. So over here, if I put a bunch of white space in the beginning, it doesn't matter anymore. That got stripped out. If I didn't have strip, we'd see that password would have a bunch of spaces. Why did I do plus equals? Because I could. It's no different than doing this. I wanted to show you that that was a valid option. Okay. Seth said, yep, that was another solution. Seth has came up with another solution, which is if I wanted to get rid of that last, hanging space over here, what I could do is I could slice it. I could slice it off. Password is equal to password. And the slice notation says everything from the first character. And there's a lot of focus on the slice notation in the upcoming readings. Up to, but not including the last character. So a bit of really cool Python stuff over there. I'm not really sure what you mean, Runji. I put the random in just right over here. Another thing you can do is, and this is a bit more of a pain, is that you notice, or it's not less of a pain, it requires more code, but less thinking about it. You're like, okay, I've got an extra space at the last one, so I'm just going to do it, and I need 4 words. So for the last word, I'm just not going to add that space. American uncomfortable. Okay. Okay. And the slice, somebody wanted me to show that again. Give me 1 second. So the slicing we'll learn more about in time, but my slice was, whoops, just right there. No. Stupid targets. There we go. This was the slice I did. So from 0, index 0, which I can remove like that, up to, but not including the last thing. -1 is a shorthand for the last thing. So, and aside for people who have programming experience, so this probably means nothing unless you're coming from another programming language. So an aside for people coming from another programming language, okay? Just a small aside here, right? Because I do want to move on to the other exercises. Okay. If you're coming from a separate program, from another programming language, you can, 1 second. You know, negative indices are invalid indexes. Okay. Right. But in Python, they -1 means the last, -1 means the last index, -2 means second to last index, and so on and so forth. Does it matter if it's a space at the end? Aesthetically, it does. All right. Of course, this does not, so I'm going to go ahead and work on the last bit since we're running out of time, and I'll share the code. So of course, that does not make the IT department of most colleges and businesses happy. They still want to have at least 1 capital letter and a number in your password. So for example, replace pool. So for example, we could, there's a method we could use here that's very useful. So if I take a string and run .replace on it and give it a character and give it another character, like replace the O's with E's, pool will give us peel. Make sense? So we can use this replace method to really help us out here. So I'm going to go ahead and rewind a bit to before I added in those spaces, because I really got on the side because of that. Whatever. I'll grab it with the space and then I'll remove it over here. So here's like showing 2 methods off, right? We've got pool over here, word.replace O's with E's. That's going to give us peel. And then if we capitalize the word, that gives us a number, that gives us a P at the end. Make sense? Oh, sorry, capital P. Capitalize does the whole capitalization at the beginning of a word thing. Like it's a title or something. So what I'm going to do over here is I'm going to drop in my thing over here. And if I need to make my password, what's saying over here is that we might need to add, we've got our awesome password, which is easy to remember. But sometimes they don't like these kind of things. Temple's awesome because they'll totally accept this. But other companies might not. So they might want us to capitalize it. So, or they might want a capital letter. Easiest way to have a capital letter is to add that capital at the beginning. Hard to forget. It's harder to forget that. It's there, little present tissue rabbit shelter. A tissue rabbit. Sounds very cute. Okay. And now we need to, and now I'm going to do that random standard replacement of, I'm going to replace all of my A's with 4s because it makes me look elite. Password is equal to password dot replace all the A's with 4s. Okay. Now, and then I have to show persist
It's persist rare.
Persist
processor limit.
rare processor limit. Got it.
Yeah.
Like, where is it blocking up? It makes it very difficult. Anyway, historical origin view conclude. Okay, so anyway, that should make them happy, but there's something here I want to kind of emphasize, which is the reason. Notice that I did password is equal to password.replace. If I just simply do password.replace without that equal over there, watch what happens. The A's don't disappear. This is because the replace function doesn't actually change what we're doing. What the replace function does is that it creates a new string with all the A's replaced with 4s. Does that make sense to everybody? Strings are what we call an immutable data type, meaning that once they're made, you can't change them. Anything that looks like we're changing them, we're actually just creating a new string. You do not have to redo everything if Runestone is unresponsive. Just click on load history and it should load it up. But I've been sharing my code pretty frequently. So share. Okay. So the last part, this is the cool part. So over here we've got, let's say you do have a 4-character password composed of only lower letter cases. How many guesses does it take to guess the character? We can actually write a program to create a 4-letter character string and compare it to the known password. So in other words, how long does it take the character, does it take the computer to guess this? All right. So here I've got import random, import sys. Now over here, this is important because this sets it so that the page won't throw an error if until it runs for a minute. So let's say that the person has set their password to ABCD. Doesn't matter what 4-letter word it is. It could be food. In fact, I'm going to change it to food because I'm sure we're all hungry. Okay. So guess number, that's the number of guesses it's taken. False. So I love using the done is equal to false. I love this way of doing things. While I'm not done, okay, I need to guess a password. So I'm going to go up here, grab this variable, letters. So this is a Boolean statement. So this is false. So while I'm not done, keep doing this. So while not done, keep doing this. And then notice that when we're done, if guess password is equal to my password, we're going to flip it to true. Notice that this is under challenge. So there's a reason why we're going to take 2 weeks with this kind of stuff. There's a lot of things to kind of think about and learn. While not done, our guess password is blank. So insert our code here. So I'm going to simply say for blank in range 4 because it's a 4-letter password I'm trying to guess, and I'm going to randomly guess it. I'm going to randomly guess this password, which is guest underscore PW is equal to guest PW, which is currently blank, just like password was, plus random dot choice, random dome dot choice letters. Did I import random? Let's find out. And random is important. So guess that, guess password. If those are equal to my password, then it will take them guess numbers. And so if that's the case, and now that since I'm making a guess, I'm going to increment guess num is equal to plus equals 1 to say that we've done one more guess. So now I'll run it and let's see what happens. And notice that my page is kind of locking up. So so I'm choosing a random letter. I'm trying to guess food. So I'm randomly putting together. So what is this code doing? It is randomly putting together groups of 4 letters selected at random until it comes up with food, which is this supposed person's password. So it took 561,000 attempts to do, well, 562,000 attempts if we round, to do this. And what did it do? Well, it successfully found out, guessed what the password was because we broke out of the loop. It said, hey, if the guessed password is the same as the password I have, print that we found it after this many tries and print done. Save and run again. So notice again, this seems to lock up the page because it's actually like doing stuff over here. And 561,000. Wait, no, it's still going. That was the last time. So the page is slowing down Firefox. Speed up your browser. Stop this page. Now you know why that it says that we set the execution limit for a minute. There's actually no guarantee that it would end because it's completely random or statistically random. So this took 1 million tries to find it. To find that to find that. So it can so as they pointed out, it can vary wildly from less than 10,000 to over 500,000 guesses. So if we increase this, the longer the password is, the longer this will take, by the way. Like over here, if I change this to foods, so now I know I'm guessing a 5-letter password, right? Now it's probably actually going to time out on us, meaning that it's going to stop running. I'm running on a fairly beefy laptop. It's an i7. It's a mobile i7, so it can do this, but it takes time. What happens if you change the 4-letter character? So while we're waiting for it, let's just think about the math of what's going on here. Where's my bar for it? Oh, let me guess. Is Zoom crashing again?
Yeah, you trying to show us something that's not, there we go.
I was looking for something, but yeah, Zoom crashed again, which is annoying. Oh my God. So annoying. So where I put the letters are over here. Yeah, it's no worries. Yeah, my computer's timed out on it too. Now, why is that? Well, it's just the number of combinations that we did, right? If you've got 26, let's think about this for a second. How many possible letters guesses was it going through? Well, if I've got a 4-letter password and we're using only lowercase letters, that means there's 26 possible letters for the first thing, 26 letters for the second letter, 26 possible letters for the third, and 24 for the fourth. So in other words, that's 26 to the 4th power, 26 times 26 times 26, 26. That is how many possible different combinations that our poor computer had to sift through to possibly find food. And it wasn't doing it in a methodical manner either. It was just doing it random. So that was over 400 or over 450,000. Now, if I decide to now upping this to 5 letters, increase the search space by 26 times, which brought us up to 11 million. So this is part of the reason when we are using like something like a 16-letter password, we're dealing with this many combinations, even if you're just doing undercase letters. Make sense? Whereas if you're doing 8 letters, if you're doing your standard random 8-letter generations, we have 26 letters plus 26 capital letters plus 10 numbers plus let's go with 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 possible shifted symbols. This is a much bigger number, much bigger than this number. So length is really what matters in terms of making passwords hard to crack, not making them complex, but basically.
So wouldn't it make more sense to have just letters than to incorporate numbers too?
Yeah, it's easier to remember.
Right. So how come all of your passwords?
Because
ask
they're
for
dumb.
your-
It's the point of the comic. Through 20 years of effort, we've successfully trained everyone to use passwords that are hard for humans to remember, but easy for computers to guess.
Ah.
All
Gotcha.
right.
Well, did you see the Edward Snowden on passwords when he's interviewing John Oliver? And his
I think I did. So let me put in the sorry, 1 second. So 26 26 to the 4th. Here we go. And now I've went ahead and shared the code with you. There you go. So just be sure to load the code and run it so you can get credit. So let me go ahead and stop sharing. Conrad asked a very excellent question. So class is dismissed if you want, because we're at 3:21, but I did share the code. But Conrad asked a very interesting question, which is, what if we just make the computer go faster? Then the problem will solve faster. But like, even if you're making your computer go twice as fast or 10 times as fast, that's still not going to catch up to if I just make if I make my computer twice as fast, making my password 1 character longer more than negates that. And computers typically get faster. What is Moore's law? But I mean, computers get faster like that, but yeah, about twice as many processor. Yeah, something like twice as many transistors every 18 months. I mean, but that's starting to even out. We're getting to kind of diminishing returns as far as we can do that. Yeah, Andrew, do you have a question? You had a question about Canvas? Is it a personal issue or a class kind of general issue?
It was it's kind of personal, but I can just say it.
If you're talking about if you have a bunch of zeros from the textbook stuff, don't worry about that. Is that your question?
Kind of, but not really. I was just saying I have everything turned in besides I guess those textbook problems, but my grades also pretty low.
Oh,
considering how
have you demoed everything?
I believe so.
Okay. Then don't worry about it. Make office hours. It's probably just an administrative issue.
Okay.
It's probably just calculating in some zeros because there's probably just some zeros from stuff that hasn't been imported.
Okay.
But I would still yeah, when it says complete, it means I haven't graded them yet. So I'm gonna work on running the grader tonight during my office hours.
I have a question about chapter 3 and 4.
Yes.
So I couldn't finish chapter 4.
Okay.
So is that
that's not an issue.
I get okay.
If you,
because I was thinking if I'm probably gonna get deductive points probably, but
you keep for the textbook, it doesn't matter. When the grader sees that you've done it, you've done it.
All right. Yeah.
Doesn't matter if it's now or a week from now.
All right. Thank you though.
Yeah, so again, the textbook, when it comes to those textbook assignments that they have, the textbook readings and the textbook exercises, the due dates on there are pretty soft. But also I want to warn you that it's very easy to fall behind.
I have a question, Professor.
Yes,
So for lab 4, like I didn't really understood how do we do like the grid thing, like the squares.
that's okay. What you're going to have, so did you successfully do the row?
No, like I typed in the code, but it's going like a column, like 2 columns with 2 rows.
Gotcha. So when it comes, so for this one is again for lab 4 covers both week 4 and week 5. Okay.
Mhm.
There isn't going to be a lab 5 because lab 4 is lab 5 as well.
Yeah.
So for the grid, what you want to do is have the function that draws a square. Then the draw row will call draw square. Like say you want to draw a row that is 5 squares long, then you'll have a for loop that you call draw square 5 times in while moving, and you move the turtle forward every time you draw a square. Does that make sense?
Yes.
And then for draw grid, what you're going to do is that if you want to draw a 5 by 5 grid, what you do is you call draw row on the turtle. Okay.
Yeah.
And you do that 5 times. Just every time he finishes a row, you go down to the next, you adjust it so the turtle goes down to the starting position of the next row. And you can figure that out with some math about based off of how big the square size is and how many squares you just drew. Does that make sense?
Yes. So like if I do like a draw my turtle dot forward, so what should I write in the bracket for the row?
Well, my turtle dot forward will move the turtle forward a number of squares. So you just draw however many, whatever the size of the square, whatever the size of the square is, that's how far the turtle should move when he's drawing a square. So most of the drawing is going to be happening in draw square, and most of your functions are going to be calling draw square, if that makes sense.
Okay, got it. Thank you.
Try to think of you want to try to think of that assignment in terms of building that up from pieces that you're building. So you're
Yeah.
taking these smaller pieces and building and using them in the much more complicated pieces.
Okay. Yeah, thank you.
Mark, if you're
Professor,
yes,
would I be able to show you my code for the grid, please?
let me stop recording.
Sure.
1 second.